right? So where this 0.5 is coming from? 0.5 is coming from change in total cost, 3.8 minus 3.3, right? 3.8 minus 3.3 divided by 2 minus 1. Answer is 0.5, right? Where this 2.1 coming from? 15 minus 12.9 divided by 10 minus 9, right? So change in total cost divided by change in quantity, right? Okay, now I'm going to give you 15 minutes to make the graph, right? So in order to be standardized so that everybody make the same graph, what we are trying to do here, we will be following this one. So you take quantity here with the difference of 1. So on x-axis, you take interval of 1. So you see 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And on y-axis, you take the difference of 0.25. So on y-axis, you see here, you take one interval is equal to 0.25 till 3.5. So you do like this. Please note that, or take a picture here. And also take a picture of this one as well. I think take a picture of that one, and this one I will be turning out here. So I'm going to pause the recording here so that the online video watchers, they don't need to fast forward it. They just do that here by pausing the video. I'm going to be resuming the recording after our class section. Okay guys, welcome back. So all of you have sent me your picture of the graph. So let's discuss that. It should be like this one. So did you notice something? The average total cost is U-shaped, right? And average fixed cost, it drops sharply, but it never touches 0. Okay. The marginal cost crossing not both, I think all the cost. Okay, we don't have the correct data here, otherwise it's called, just ignore that one. So variable cost is also increasing. So we know that when cost increase, when quantity increase, cost is also increasing. So there are two costs that are increasing from the start: marginal cost and average variable cost. And the behavior of the fixed cost is it's always decreasing. When output increasing, it start decreasing, but never touches the x-axis here. What about the average total cost behavior? First, it start decreasing and then slightly try to from here to increasing, right? So the question arises, why we draw these curves? The answer is to understand the behavior, because we talked about that we are going to categorize our cost on the basis of behavior. And why we are doing that? In order to understand how we can minimize our total cost. If we minimize our total cost, then our profit is going to be increased, right? So we are now on a portion or on a position to talk about what kind of measures, what kind of behaviors of the cost are that. So we categorize first, we divided our total cost into various categories, two categories basically, fixed cost and variable cost, and then we develop marginal cost to understand the behavior, and then we predict the next step going to be in different markets. We will be predicting, okay, how much quantity we need to make in order to achieve this objective, minimum total cost, right? So in coming markets in which we talk about the types of market: perfect competition, monopoly, oligopoly, monopolistic competition, we talked heavily on this concept, to minimize our cost. where we need to produce to have a minimum cost, and when we sell it to the market, we will be having maximized profit, right? So this is our overall goal over. So don't just lose the sight that we are, going away from the topic. We are on the same topic that we want to minimize our cost. But before that, we want to learn the behavior of the cost, right? So we develop different methods, different measures to calculate the variable and fixed cost. First of all, we know that total cost is equal to fixed cost and variable cost. In order to learn the behavior, we converted those total cost into average cost. And then we draw this on a graph, right? So here we go. Here we go. So the average total cost is U-shaped. You agree with me? So see, look at your work here. If I give you more, if I give you more data, it would be like increasing this. So average total cost is like U-shaped curve, right?
Yes.
And then at very low levels of output, when the outputs are, low or small levels of output, see, average total cost is high because fixed cost is spread over only a few units. So what are the reason why we are having average total cost highest at 2, you see, at 2 here, at 1, see here, at low level of outputs, when we are making low level of output here, our average total cost, which is this curve, is highest, right? See, high. What is the reason? The reason is in the formula. Formula is average total cost is equal to average fixed cost plus average total cost is equal to average fixed cost plus average variable cost, right? Because variable cost is small because quantity is small, but fixed cost is high. So that's why the biggest portion of every total cost is here. So at low level of output, our total cost is high, right? Every total cost declines as output increases. Now this is the marvel of or miracle of every total cost. We are supposed to have our break, but I think this is the right time to explain all this behavior, otherwise it's going to be wiped out. So we will be having our break, don't worry about that. So every total cost is decreasing, output increase. Come on guys. This is the marvel of having average total cost. So how this is magic? Because we are increasing our production and our total cost is decreasing. The common layman objective or layman sense is that we produce more, our cost is high. But look at that. We produce more, our total cost, every total cost started decreasing. Understand? The formula says total cost is equal to total fixed cost plus total variable cost. Sorry, total variable cost. Total fixed cost plus total variable cost. So our total cost should rise with the level of output, but when we convert it into average cost, we see the marvel or the magic of every total cost is that at low level of outputs, it cost is higher. But whenever we start increasing the production, cost is dropping sharply and then decreasing. So average total costs start rising because average variable cost starts rising substantially. Here we go. Now, that miracle is now disappearing when we produce more units. So it start rising. So that's why we talked about that average total cost is U-shaped curve. So at first it's decreasing sharply at the level of output. If output increases, it's decreased sharply. So let me explain it here. So here we go. So in real life, if we put real life data and bigger data, so we just have like 10 output, but in real life we have thousands of outputs, right? So it's going to be like this. Sorry about my drawing. My touch is not very responsive, so it's a little bit deviated here. Average total cost. So what is the behavior of average total cost? It is wonderful, miraculous. Why? Because at low level of output, cost is high, but decreasing. So it means producing more gonna decrease the average total cost. Producing more gonna decrease the average total cost, right? But after a certain point, when you produce more, average total cost start rising here and then started sharply, right? Okay, up till now, what we have discussed? We have discussed the average fixed costs declining and declining, but never touch the x-axis. Why is that? Because fixed costs remain the fixed. If we're talking about average fixed cost, not the total fixed cost, average fixed cost. And average fixed cost is equal to total fixed cost divided by quantity. So quantity increasing, numerator remains the same. So base is getting higher, denominator is getting higher. So we are having a smaller numbers, right? So average is fixed cost, highest at lower level of output, decreasing when we produce more, right? Variable cost rising